So now to talk about the quantitative forecasting method. So the first one introduced in the textbook is moving average. Moving average is a very simple and easy to use forecasting method. So it uses the average sales of a number of past periods as a forecast of the next period in the future. So this is pre-specified numbers. So the firm can use really any number of months or quarters or years that they decide to use. So if a firm wants to predict October sales using a moving average of the past 3 months, then we need to look at actual sales data for July, August, and September. If we then look to predict November, we would use August, September, and October. We have all different kinds of moving average methods that we could use. So looking at this October thing again, so if we use October sales using a moving average of the past 3 months, we need the actual sales data for July, August, and September. So assuming that sales for those 3 months were 130, 170, and 120, we would add those three together, divide by three, so the number of periods, and giving us a forecast for October of 140. So the forecast for the period 140 equals the actual sales from each month, so however many months we do, divided by the number of periods. So if we use 5 months divided by 5, if we use 3 months divided by 3. The moving average, the one main decision that we need to make with that moving average is how many months do we use? The more months we use, the less the moving average reflects very recent changes in sales. So the optimum number of periods to select is the one that produces the smallest forecast error or the amount that we're off. So as we increase the number of periods using 5 months, 6 months, 12 months, we start increasing the forecast error that we're going to receive. The moving average method does have shortcomings. So it does not consider trend or seasonality in the data. So if we have inventory that has a seasonality, so we sell more in winter than we do in summer, or demand completely changes from one season to another, or that we have an inventory that follows trends, such as fashion inventory, then the moving average has to be modified to consider that trend and seasonality. We can, then we have exponential smoothing as a forecasting method. This is an easy method to use, requires little data. So we are able to consider longer sales history than the moving average because we use a smoothing parameter to uh, take care of some of that estimation error that we're going to be talking about. We should not use it for long-term forecasts. So if we're trying to predict out 6 to 12 months in the future, then this is not a good method. Then we should forecast one. If we are just forecasting 1 to 3 periods in the future, then this is a good method. In truth, the best method is a combination of things. So looking at both moving average and exponential smoothing, seeing how the results are different. So maybe we get 140 with the moving average and we get 150 with exponential smoothing. We can then go with 145 as our sales forecast, kind of splitting the average there. Okay. So when we're using exponential smoothing, what we need is the previous period's actual and forecasted sales, and then the smoothing parameter. So when we're looking at our actual sales plus a correction for the error in the previous forecast. So if our forecasted sales were 150 and our actual sales were 140, then we had an error of 10. So we were 10 off in our prediction from forecast to actual. We use an alpha then to weigh that forecast error. So the smoothing parameter can take any value between 0 and 1. The value of 0 means that the error in the previous forecast is not considered in the next forecast, and a value of 1 means the forecast for the following period is simply the actual sales in the previous period. So let's look at that formula. So we have the forecast for the period equals actual sales for the period times the smoothing parameter, anywhere between 0 and 1, so 0.1, 0.2, plus 1 minus our smoothing parameter times the forecast for the period. And we can see the graphical representation of this. So how the forecast follows more closely the value of sales of the previous periods whenever value of alpha is high. So we have an example here where we have our actual sales are the solid line. And you can see that our actual sales are very volatile. So we have high peaks and we have low peaks. Then we have two different forecasts, one using an alpha of 0.8 and one using an alpha of 0.2. So you can see that the 0.8 follows this trend line, this forecast line, follows our actual results much closer than the alpha of 0.2, which really smooths out that sales line. It would be really reckless of us to use this type of smoothed out forecast when we have an actual volatile forecast. So we're better off going with a 0.8 in this and using a forecast of 0.8 for our smoothing factor. Then when we look at exponential smoothing, we can add trend correction to this. So when trends go up or down, our forecast needs to be adjusted up or down. So this is done by adding or subtracting a quantity known as trend value. So the trend value looks at what is our current period's trend, previous period's trend, and a trend smoothing parameter. Okay. Then once we've used trend correction, we're looking at if that B, that smoothing parameter, has a low value, then the trend value for the next period relies more on the previous trend value. And if our beta has a high value, this indicates that the trend value relies more on the current trend. So again, where we're looking at selecting the beta that produces the smallest forecast error. Now in this class, all of this information is informational. So we're just talking about all of these different methods, and we're not going to be doing all of this mathematical analysis and statistical analysis. So all of that occurs in operations management. So if you take an operations management, you've already done some of this forecasting, and if you plan to take operations management, you will do this forecasting in the future. So then we get a trend corrected forecast for our next period. What you can see is what it really comes down to with sales forecasting is that we need to really understand our business and how inventory moves in and out of our business. This deep understanding of how our business works allows us to make better decisions and better future estimates. We might also need to smooth with a seasonality index. So if we have seasonality with our sales data, such as we have different demand in winter than we do in summer, or we have demand at holidays that we don't have at other times, then we would use a seasonality index. Okay? So we use a percentage for that. So if sales in a high season are 20% higher than average, we would use a seasonality index of 1.2, or that we're doing a 20% adjustment to those seasonality to predict the high season months. So then in the next video, we'll talk about how we incorporate technology and operations and planning into our sales forecast.